We have to get you that picture.
Of?
Chris Roman.
Oh, yeah.
Don't let me forget.
There's a backstory to this.
Chris Roman
there's the original build pictures of Hercules on the shop computer. And Chris Roman was part of the wiring for the original model. And so he looks like what you would expect grad student Chris Roman. And so, as Chris Roman's grad student, he wants a picture. He wants that picture.
I see. That's fair.
Something you can't unsee.
Todd, one of the designers of Hercules, looks about the same age then as he does now.
Yeah, that's true. He ages well.
He's from the future.
And
Confirmed.
Confirmed.
The frame though is like shiny.
That'd be nice.
The frame of Herc in the picture.
Yeah, it's shiny. It's a really neat historical like bit that we have.
Why are the numbers tracked manually? Like, why is it something that you guys actively maintain as opposed to?
Because it's more intuitive when you make the call as to pulling the vehicles based on number changes. Right, so all of the numbers, except for the ones on the gauges, are scanned on a regular basis just as part of piloting. We do have, you know, like, for lack of a better term, an LED that'll go off if there's a leak or if the temperature or humidity gets too much. But the sometimes you're going to make the call based on, well, you know, like all the different things involved. You know, and sometimes it does include like this is the last dive, you know, of the season or something like that. You know, like you might push the envelope just a little bit more. It depends on how far, like how deep you are, how long it's going to take you to get back to the surface. So we could log the numbers, but for the most part, we don't need the numbers logged. We need to know we need to know in the present what they are and what they were recently.
Robots can't take all our jobs.
So by taking the numbers manually, you compare to what they were previously, and you know what they are now. If they were just logged, then it's just a background process. Robots can't take all our jobs yet.
Megan, are there any future robots?
Yeah,
that we
being
should
from the future.
I'm sorry, that's highly classified information. Can't let you lowly past people know.
I thought we were future people that you're visiting.
Yeah, I thought you were from the past.
It's all relative. The uncertainty is high.
So the true question is time linear or circular, right? There's some really interesting sci-fi novels in which time is circular or spherical. I can't remember which, but
they have a couple like very funny Futurama episodes about those concepts too. He like cycles through the end of the universe, through the Big Bang, back to the present, and he's like, "Oh, this universe is like a meter above the last one," and like falls on his previous self. Like, you know?
Alexis, I have a question for you.
Ah.
Yeah, sorry.
No,
it's a good one.
We're at 33.
So what are some of the things that like like if this were an amazing like dive to end all dives, what do you want to see down here tonight?
a Nautilus.
A Nautilus, yeah. I mean, I don't know. I people ask that, and I feel like I actually generally am pretty excited when we just see like yesterday's dive for me was really exciting to see the amount of scleractinian coral that we did. I know like a lot of it looks dead or it's not like a super vibrant color, but just the quantity of it at depth, at that deep, which was around 1,000 meters, that's the most that we've seen in any of these seamounts in the Pacific. And so that's like pretty significant considering we don't know. Well, we do know that they're living below the saturation horizon. So they're living where it's actually really difficult for them to build their skeleton. So what's interesting to think about is, did those start growing a long time ago when they were growing above that saturation horizon? and now they're still living, but they're not thriving. How are those communities changing over time?
Right.
Stuff like that. I also really just like to see high density coral. So anytime we come up to a ledge and there's a bunch of different types, it's really awesome. I've had the opportunity to see like a fish fall. So like we've come across a swordfish that was dead and was being eaten by sharks. And so like that's insane.
That is the most, I saw that video before I found out I was coming on the Nautilus, and I lost my mind.
Yeah.
It was the coolest thing I've ever seen, because then a grouper comes around and like eats a shark, and so you guys should all like Google that. Like, what would they need to Google to
It was called "Oh My Grouper, Look at That Shark."
Oh My Grouper, Look at That Shark.
"Oh My Shark, Look at That Grouper," something like that.
Goodness gracious, it's amazing.
Oh gosh.
But that was in the Atlantic, so we don't have the same swordfish populations out here, I don't think. But
I have a question then. So you were just talking about the scleractinian and how like it's below the saturation horizon. So below where it would have enough
essentially ions
in the water to build. So, but these are really, really old living corals.
Yeah.
So thousands of years old?
I mean, it's hard to tell, but just based on the amount of skeleton, likely they've been growing for at least hundreds of years, growing and dying and growing and dying, and that's what we expect for scleractinians. You often find a lot of dead rubble around where there is live coral. It's just like their growth pattern, but yeah.
Wow. That's pretty fantastic.
It is, and the species we saw yesterday, Madrepora, again, like definitely haven't seen in that high concentration before, so super cool to see those communities, and hopefully we'll see, if not that, just like something similar here, and get a feel for what we're seeing just off of the island as well, because it's interesting to think about like the comparison of island versus a seamount that never reaches the surface, because is there nutrients coming from the top, from that seamount being so tall, that's really fueling those communities, versus these deeper ones where you don't have quite as much, you're not going to have quite as much upwelling or current flow probably.
So yesterday we were climbing up, essentially not really a seamount, we were climbing up the flanks of an island.
Yeah.
But the difference being that like this seamount never emerged to the point of being an island, whereas yesterday we were at Howland Island National Wildlife Refuge. So that was an ancient volcano that formed a fringing coral reef, and now what was above the island has now pretty much eroded down to essentially at sea level.
Yeah.
It's about 5 meters above
Looking at it from the ship, it was like this tiny little sliver.
Tiny little sliver of like essentially just coral rubble.
Yeah. With
very little vegetation, but a ton of seabirds that are still calling it home. But those seabirds are out foraging for hundreds and hundreds of miles, like around that, bringing back
4 or 5.
The contents of their stomachs, basically, and pooping on the island. So essentially, like collecting massive amounts of nitrogen from the ocean around it and concentrating it on that seamount that will then wash into the nearshore reef, which then brings in more fish. And so it's really aggregating a lot of life around it.
Totally.
In a way that this seamount won't have.
Yeah.
Because it doesn't have anything at the surface.
Right. And it never reached the surface. So sometimes we go to seamounts that at one point were on the surface and they have that kind of carbonate cap. What we saw on the end of the last 2 dives, where the geology changes.
Do you have a prediction for this one?
And it has never reached the sea. It has never reached the surface, so we don't predict there to be any carbonate at the top. Is that what you're asking?
Well, the question is, has it ever reached the surface?
I don't think so, no.
I don't think so. Although, interestingly enough, we don't know a ton about the geology of, say, like Baker and Howland, which are the 2 islands that we've been exploring the last couple of dives. And so they're actually a lot older than other islands that we find, say, in the northwestern Hawaiian Islands. So in Papahanaumokuakea Marine National Monument, the oldest still emergent island is Kure Atoll, which is younger than both Howland and Baker, but is nearly gone, right? It's like there's almost nothing left. And so we don't really... Howland and Baker shouldn't still be emergent. They shouldn't still be there. They're not in a place where like coral is really building around them.
Yeah.
And so just with seafloor like falling essentially
or
over
sinking,
time, sinking over time, they shouldn't still be emergent. It's really interesting, right?
Yeah.
I don't know.
Yeah, we were having a conversation over, I don't know if it was lunch or dinner, can't remember, with Dwight who has a background in geology, and it's really interesting just to, I mean, I'm studying deep sea ecology, but to hear him talk about the geology and the formation of all these different seamounts from a geological perspective, it's just something that I am now becoming a lot more interested in. Like, I need to go back home and do more reading and try and understand kind of the dynamics of how some of these formed over time, just to think about how that can influence these communities as well. It's just crazy.
None of these disciplines are
no,
isolated.
not at all.
They're all interrelated.
I expected 14.
Yeah, I kind of felt the same way the last couple of days, Alexis. Like, coming from a chemistry background, I can write out what's happening on a single atomic level, but that doesn't really capture the macro scale of what's happening at these interfaces and between the geology and the ocean here.
Yeah.
I think it is really, the idea of learning more about geochemistry is all of a sudden really, really interesting to me.
Yeah, definitely.
Brandon, I have a question for you. So we've been in this conversation talking about going into the past and, origins of life.
Yeah.
As a chemist,
you're probably right.
Do you have anything to say about the chemistry of life on
You're
Earth?
right. No,
I'm hinting for chemosynthesis here, in case you didn't notice.
Really teed it up, huh?
That I was dropping those breadcrumbs.
Really teed it up for me.
Follow me into the wilderness, Brandon.
I'll take your hand and you lead me on this journey. Yeah, I mean, I think it is interesting to kind of ponder early Earth. There's so many mysteries about not just how we got here, but how life got here, and why we aren't just an icy snowball anymore. Why oxygen exists at such the perfect concentration for life, right? I mean, it's kind of interesting to think that oxygen is very combustible. So if there were 4% more in the atmosphere and you lit a match, then no more Earth.
Oh, that's crazy. I've never thought about that.
So yeah, I mean, it's wild to think we've got this perfect balance.
So this is why we don't plant more trees, right?
Well, one of the biggest reasons we have oxygen is because of our oceans.
Oh, definitely. Yeah.
And if you go back to really, really, really the beginning of Earth, it was unrecognizable from what it is today. There were no oceans. There was no oxygen. It was kind of a dead planet. So it took a long time for life to be able to be sustained here.
Yeah.
And that was probably key to life forming in the first place, right? You needed these insanely acidic oceans interacting with the ocean floor, and that interface is probably how the first protein came to be. And then from there, all of a sudden, Earth was transformed, and here we are. And that's just wild to kind of wrap your head around the scope of that. How many things needed to take place, not just in chemistry, although that's just kind of my skewed viewpoint, but once that scale went from chemistry to biology to geology and so forth, it's kind of miraculous.
Geology first, then biology. But yes.
I guess so.
It's wild that life is starting in the ocean, and that's the environment that this comes from, and yet it's the last thing we're exploring. It's the last thing that we're able to really begin to understand, even.
I mean, at that point, it's where the technology comes into play, right? We've only recently being past 100 years or so. I mean, people have been exploring the oceans on wooden ships and whatnot, but really being able to see the sea floor at the resolution we're able to see is pretty recent development, right?
Yeah.
Yeah.
But I mean, at the same time, we landed on Mars in what, 1972? I mean, that's insane.
Yeah.
So we can go 50 million miles across our solar system, but not have a general idea of what's at the bottom of our own oceans.
That's true.
What's crazy? It's cool that you just mentioned 1972 and landing on Mars, because 5 years after that was the first time people discovered hydrothermal vents. So 1977 was the first time that we ever knew chemosynthesis was not a concept before that.
Wow.
So we were on Mars before we realized that a large portion of primary production on our planet comes from chemical reactions
And-
in the deep sea.
And in 1974, Howland and Baker were designated national wildlife refuges. And we started protecting these remote islands out in the Pacific, which were later extended the boundaries to the Pacific Remote Islands Marine National Monument, which is now close to or over 400,000 square miles of our oceans protected.
Quick correction too, so I don't get yelled at.
Oh,
It was
sorry.
1976.
Oh, okay.
Saw
Even
that one
yeah.
blip of Argus, like way right next to Herc.
Man, it's all
It was
coming
like
together.
right there.
I know.
The
That's
total
crazy. When
pattern.
you make a little
Horizontal going
timeline.
forward.
Yeah.
Because of our sound speed.
Yeah. And if I remember correctly, the OET president, Dr. Robert Ballard, was on the cruise that found hydrothermal vents.
In the Galapagos.
Yep.
Oh, wow.
Yes, that's
Man,
right.
can you imagine how stoked they must have been?
Well, so they actually didn't know anything. I mean, it was all geologists. There were not biologists on board.
Right.
They didn't know what they'd found. They literally
Right.
Well,
they
they
just
were
knew that they
using
found
heat
life.
flux
Right. They were looking.
model.
right,
for
yeah.
heat.
Yeah.
Like, but from a
And then they
biological
found,
standpoint,
like, these
they
red Poconophrin tubers,
Yeah.
and they like bring it back and put in some
They put-
vodka.
yeah, they
That
didn't
was
have
maybe on the
ethanol to
ship,
preserve
yeah.
anything. You know.
Wait, really?
Yeah.
No kidding.
Yeah, they asked, like, because back then people could have personal alcohol stores, so they said, like, does anybody have any alcohol they're willing to give up? Because that apparently is the best thing to put something in to preserve it in if you don't have
Yeah, vodka is really good for
molecular grade ethanol.
Oh, wait. So a bunch of geologists are out
Apparently, they tried to invite biologists, or so I've
And they
Oh,
refused.
okay.
And they were like,
And
we're
they were
not
like,
going there. There's no life. They're apparently like, hey, you should come. We're going on this thing. They're like, there's no life there.
Oh
That's
my
not worth my
gosh.
time.
I think
And
he
then-
describes it as part of the incentive for the telepresence
Yeah.
technology.
Well, no, the telepresence was more than that. The story I heard, at least, was like, once digital cameras came about and there was a monitor inside the subs where you could see the video streaming in that you were capturing.
Oh, yeah. Keep going.
Bob, at least the way Bob tells the story, like they would some people would start looking at the monitor more than looking out the actual windows of the sub because it was clearer to see what was happening. And then the notion was like, why are we even there if we can just look at a really high definition camera and be up on
Send
a
your
ship or
soul
somewhere
down
else,
there.
then we can actually stay down longer and do more work and all these things.
Yeah, the argument for like remote sensing versus submersibles is like an interesting one and pretty clear to me.
Yeah.
The
Yeah.
benefits of that.
I mean, it just
Oh, it's relief in
it
general.
does just go to the point of the importance of like protecting things, especially when you don't know what's there, right? There's so much we still don't know. And that's why like having these
Oh,
like
Trevor
large
came up and
spaces
told
of
us to
protected
stop.
ocean
Yeah.
are so important.
He said, I'll stop,
And
do
that
this test.
trips like this and the Okeanos and all of these deep sea explorations that are really showing us what's here for the very first time that will allow us to like help protect these spaces.
Yeah. And I mean, we talk about the geology, the biology. We're talking about macro scale stuff that we can see because that's, what we can do with the video. But on a microbial scale, it's even, I think, more significant. There's still so much work to be done to understand the small, tiny organisms that are living in the sediment. What are they processing? How much are they contributing to like the whole overall cycle? And when it comes to like vent and seep areas where you have those communities are even more important because they're the ones that are actually processing the doing chemosynthesis. So like we've discovered a lot over the last couple decades as far as macro scale, but I think in the future it's really like the microbial scale that's going to blow people away. It's just, I mean, microbiome is just becoming like a household term for some people. We have microbiomes. Everything has a microbiome, and without them we wouldn't exist.
Right.
So I think there's still so much to be learned about that. Like for deep sea corals, there's like a couple people in the world that really have started to do that and think about how their microbiomes are influencing the coral themselves. So yeah, they're still.
I just realized that I did a terrible job in the introductions because I was just thinking about if I was going forward or
You
backward.
didn't say who you were.
I didn't say who I am or what.
Oh, I didn't either.
Yeah.
Me neither. I don't think anybody did.
I'm just going off about conservation and National Wildlife Refuge. So in case and was like, who is this person? So my name is Holly Richards, and I work for the U.S. Fish and Wildlife Service, and I'm out here because we manage some of these remote islands, and they were initially began to be managed as seabird colonies because that's what we could see above the waves, and now they're all included in the Pacific Remote Islands Marine National Monument, which is one of the largest protected marine areas on the planet that we manage in partnership with NOAA. So, yeah. And it's we're coming into a watch change.
It should never move from there, so it should be fine.
So you're going to start hearing some new voices as we get some new folks in here.
And hopefully you enjoyed our philosophical musings on time travel and the deep blue, blue sea.
Yeah, they're welded in place. I know.
Check 1 2 1 2. Set 1, set 2, set 3. Record 1, record 3. IPOD sensor is active. Where's my light? Watch change in progress. And we are, what watch is this, 8 to 12? Yep.
Yep, 8 to 12.
I think I finally recovered from standing on those watches at the beginning.
Hello to everyone at home. We have now transitioned for the 8 to 12 watch. We're still making our way down to an unnamed and unmapped seamount located to the south or northwest side of the Baker and Howland Islands unit of the Pacific Remote Islands Marine National Monument.
And Emil Petroncio in the back row in the watch lead seat here. And we are on our way down to 3,000 meters for this one. Deeper than any of our previous dives. And hoping to see at this depth maybe some iron manganese nodules on the seafloor. They're typically found deeper, say 4,500 to 6,000 meters deep, but they've been found at these depths elsewhere, and so we're hopeful to get some samples of manganese nodules. Otherwise, we'll be transiting up a fairly gentle slope until we get to the ridge of this newly mapped seamount, and we'll be ascending a portion of it that looks to be nearly vertical in places, at least a 45-degree angle. But yeah, this is the first time this ridge has been mapped by any sonar, and it's formed in a cross shape, almost right angles between the 4 ridges that make up this seamount. In the satellite data that we used to find it, the estimated bathymetry from satellite, it just looked like a round, symmetrically round seamount, but those estimated depths are based on the slope of the sea surface. There's a bulge over seamounts due to the stronger gravity there, and it's only an indicator. And so we found that the estimated depth was 200 meters off. It was 200 meters too deep. So we'll be ascending a ridge to the summit of the seamount, which is at 1120 meters, 1,120 meters. Hopefully seeing some corals and sponges along the way, as we did at Howland Island and Baker Island and the seamount south of Baker.
Yeah, it's strange that cross you were referencing, Emil, is almost on cardinal headings too.
Yeah, yeah.
It's like a little compass down there.
So that cross is formed by slumps, failures of the sides of the seamount that cause, you know, landslide down. And so the steep area that we're going to be ascending should be exposed basalt and probably manganese encrusted by this time, but at least it'll be older basalt, and hopefully get a sample on our way up that steep part. Good.
How do these manganese crusts form?
It's a really slow process. There are manganese and iron and other metallic ions floating around in the oxygen minimum zone. Below that oxygen minimum zone, which is around 500 meters, they become oxidized, and they accrete onto the exposed rock. So they form on areas that are scoured by the currents. So they don't form if sediment is present. So they form on exposed surfaces of the seamount. And they're very slow, that 1 to 10 millimeters per century deposition rate, and they also incorporate other metals that are naturally occurring in seawater. Rare earth minerals that are very important for cell phones, electric vehicles, wind turbines. You know, a lot of the green energy is dependent on these rare earth minerals. So
lime scooters.
The list goes on.
If you look at where we are on Google Maps, Google Earth, it shows up as very conical. So
Yeah.
it's a great example of how you look at Google Earth and you think, oh, we've got the seafloor mapped, and then you look at the reality of what we find when we use sonar and multi-beam to take a look down there, and it's nothing like what you see on Google Earth or maps. We're like 1.6 north, 177.6 west, I think. Just almost in a straight line, like there's a hot spot that formed Baker and Howland. We're north and slightly west of them.
Yeah, and on the transit up to the Howland-Baker unit of this Marine National Monument, we passed Winslow Reef, which is in the Phoenix Islands protected area, and mapping along the way, and we helped show that where it appeared there was a seamount in the estimated bathymetry, there wasn't anything. So it was kind of a, I guess you could call it a bleed over effect from a nearby seamount. Made it look like 2, but it's actually just 1 that.
Speaking of transit, we have a lot of that coming up, I understand.
It'll be about 3 days between here and Johnston Atoll unit.
Tomorrow is Wednesday, so transit
4th.
Thursday, Friday, Saturday?
Tomorrow night, Thursday, Friday, part of Saturday, I guess. But
Okay.
actually, I'm not sure the date that we'll be at the. We will visit a seamount that's in international waters before we get to the Johnston Atoll unit. So yeah, that might be Saturday. It's a big Pacific.
Yeah. I wonder how many miles it is from Apia, the route we're taking, to Honolulu, and then to San Francisco.
To Honolulu, it's a roughly 3,000. It's over 3,000 nautical miles
that we're sailing.
Yeah, and then from there to San Francisco, I'm not sure.
Probably the same again, 2,400
yeah.
or so. It's about 6,000 miles. I know one of our Coast Guard, what are they, cadets? Several years ago, got swallow tattoos, and there's like one swallow for every like 5,000 miles.
Huh.
That they travel by sea, and I would think my body's not big enough for that many swallows. They'd have to be minuscule. I can't imagine how many miles some mariners log at sea. I'm sure that data is here somewhere on what the Nautilus does every year.
Yeah, so we've got Coast Guard cadets and Naval Academy midshipmen who take part as interns, navigation interns on Nautilus each summer.
Is the Coast Guard, no offense to them, just piggybacking on the work you did in establishing that internship?
No, I think they worked in parallels at like maybe a year later. I think that the Coast Guard, but
the Coast Guardsmen, is that the term now?
Yeah,
have been solid.
Good. Yeah.
Yeah. I've been really pleased with them. Did I tell you the luggage story of one of our Coast Guard cadets? He had accumulated so many souvenirs in all the ports. He was on board for like 90 some days that it wouldn't fit in his bag to go home. And so we were in port, I think in our home port of Los Angeles. And I was out running errands, and I stopped at a thrift store and bought him an extra suitcase for $15 so he could get all of his stuff home. And I assume it must have been the next break he'd gotten from the Coast Guard Academy, but it was 2 or 3 months later. I got a check in the mail at my house for $15 from him. I had no expectation of getting that. I mean, he's serving our country. I was buying it to help him out of a jam, not expecting he would ever attempt to pay it back. But
wow. That's really sweet.
Yeah, I think for some of our Service Academy interns that come out, this is about as good a gig as they can get.
Just going over some logistical planning here with the navigator, Rennie. Yeah, we're having quite a strong current down here, over 1.5 knots.
Wow.
Really deep. Surprising this deep, yeah. So hopefully it's just a temporary tidal current issue with an internal tide. The internal tides are funny. They're like, it's like Goldilocks and the Three Bears. They like to propagate at an angle through the water column, and if the slope is too steep, they reflect back. You know, when they're generated and they hit up against a slope, if it's too steep, they'll be reflected back to the seafloor. If it's less than the angle that they like to propagate at, they'll skip forward into shallower water. If it's just the same angle, if it's just right, then they get very strong bottom turbulence.
And how can you get data to study large volumes of the water column like that? I mean,
well, I used an acoustic Doppler current profiler.
ADCP?
Yep, and a CTD, a conductivity temperature depth probe, and went back and forth along the axis of Monterey Submarine Canyon.
So you're doing point-in-time measurements and creating that over a time scale.
Yeah, it got time series at each end, and since the ADCP was running continuously, I spatially averaged that data as if it were several more stations in between.
Right.
And got a beautiful snapshot. Yeah,
assuming that's a linear transition between those points.
Yeah, and these are fairly large scale waves. The internal tide waves are, you know, say 30, 40, 50, sometimes 100 kilometers in length. And I was looking at an area that was maybe 10 kilometers.
Have you looked at any of the data from the benthic crawlers on the regional scale nodes component of the National Science Foundation's Ocean Observatories Initiative project?
No, so these guys
they
are
have
crawling.
shallow water crawlers and deep water crawlers that go from 3,000 meters up to 200 meters, and then they have other devices that go from that 200 meter mark up to almost the ocean surface.
Oh, okay, profiling.
Yeah, crawling all the time. And I wish I could provide the URL. Interactive Oceans dot something dot something. Can't be that hard to find.
I'll bet somebody's looking at that data.
I'm looking it up right now. I'm sure I have the URL stored. They just did a whole facelift to it, so now you can create your own graphs. And
Nice.
well, it says interactiveoceans.uw.edu, but I don't know. I'll know in a matter of moments. Interactiveoceans.washington.edu. What does I like to say? Edu.
Edu. So the same satellites that show us what these seamounts look like by looking at the mean sea surface shape are also accurate enough to show these internal tides propagating north and south from the Hawaiian Ridge and some other large ridges in the ocean, and that really opens some eyes to see how far these things are propagating. We may be influenced at the Johnston Atoll unit. We may be influenced by internal tides that are generated along the Hawaiian Ridge. So they propagate down that far or further.
Huh.
So they're running around all along the mid-ocean ridges, seamounts. It's helping to mix the ocean. So the ocean, it's important to understand ocean mixing because that tells you how temperature is dispersed and through the oceans, transported through the oceans. And so all the mixing at the surface is done by the wind, mostly by the wind and breaking waves, and then there's nothing in the mid-water column. And then at the seafloor, it's internal tides. That's how the ocean gets mixed.
So as a physical oceanographer, do you look at or study the so-called patchiness of the ocean in that, you know, regions, phenomena are not constrained to normal linear shapes or logical boundaries?
Oh, so like blobs?
Yeah, the blobs of either biology or DO or salinity or whatever, that's not, you know, from this strata to this strata over this 4 kilometer range, it's exactly like that. It's just this anamorphous, undefined shapes that have these properties, and the biology does not intersect or align itself with what one data point is doing, which makes it difficult for humans to understand what's going on in something so vast, or at least that's how it was explained to me.
Yeah, you need to understand the physical background that affects, the biology. So water masses, people want to understand the water mass characteristics and how they move, how they evolve, and what's one big help in that area, at least in the upper 1,000 to 2,000 meters of the ocean, is the Argo Drifter program, because that's measuring temperature and conductivity.
That seems like it's really picking up momentum.
Oh yeah, there's I think maybe over 3,500 drifters now out there. International effort. The U.S. has quite a few out there. But that's complementing. So every 10 days you get a snapshot of the sea surface shape from the radar altimeters. And every 10 days these Argo drifters pop up and kind of complement that space-based measurement.
That's a great program.
Really, yeah. Making the ocean models much more accurate. So ocean modeling is starting to become operational in the sense that weather forecasting is.
I've heard that we can really leverage the big data tools that corporations are using to model consumer behavior and buying patterns and et cetera. That type of understanding where you can look at, 10 million accounts and buying patterns and know how to price milk on a certain day, that those same type of tools may be helpful in oceanography.
Yeah, well, what we're trying to get at is Earth system modeling, so coupling the atmosphere and the ocean and the ice all together in a comprehensive model because they all interact.
It's a big model.
That is, yeah, you need some major league computers. But we're heading in that direction.
There's some image processing and some data set manipulation I know was going on as a while ago, because I know they were using an army of Sony PS3s tied together utilizing only the graphic processing units to manipulate data, because they're so good at doing image manipulation.
Who was doing this?
I don't recall.
Oh.
Yeah. I think that was an article on Wired from 2017.
Wired's got some good stuff.
Occasionally, yeah.
Yeah. Not a sponsor.
Ding.
Let's pick up the slack for Sam since she's not up here so far.
That was a call out.
Yeah,
shots fired.
Let's start scheduling interactions with her all day tomorrow, back to back.
Both ways.
2:15, you have Bill's Backyard Barbecue. And at 2:25,
Bill's Backyard Barbecue. Yeah, 2:25, it'll be a modern art museum where no one could figure out if it's art or an interaction.
Right.
That interaction is actually interpretive dance. Yeah. Okay.
All right.
Okay.
So the white is a 100-meter contour already?
Yes. And the other one is 10. The black is 10.
So even this deep area here is fairly steep.
Wait, what's that?
Yeah. Yeah, so that wall is going to be
that's vertical, yeah.
Funny scenario.
Yeah.
Oh, what's that?
Real funny.
Maybe near the base we could get a rock sample out of it or near it.
Yeah. I have a feeling there's going to be a lot of rocks here.
You still experience the current, Herc?
Not right now.
That's good.
Now it's all good.
Should I put my jacket on?
There we go. There's the bottom up, sub bottom.
That was quick.
Yeah, we're 160 meters off.
Thanks, 48.
Yeah, much appreciated.
Took all the blue for us. So one of our viewers is wondering, what would be a jaw-dropping geological find on this dive?
Hydrothermal vent.
Yeah, that
Do
would
you
be.
think it's possible
That
for
would
us to
be,
find one
since
here?
There's no active volcanism in this area, so that would be jaw-dropping.
That would be jaw-dropping.
I think
Mud volcano.
A dense field of manganese nodules on the floor here would be jaw-dropping because we don't know what's down there. But it'd be interesting. We want to find out the mineral content of these nodules. And I think a jaw-dropping result of what we collect would be, dating this seamount and having it be like way out of line with what Howland and Baker are. But I would expect this one's probably around the same age or a little older, 74, 75 million maybe.
Yeah, I'd like to get your input during this watch, Emmo, if you can. I know we're just, as Bob Ballard explained well in one of his specials, in a backyard with a flashlight trying to understand the forest.
Yeah.
But if you can try and tie what we're looking at in this new cross-like to what probably at one point in time was a conical seamount, like how the collapse happened, and if we see signs of that.
Yeah, we may see rubble at the base of this steep area. But I think that's why you get these star-shaped seamounts there. It's just, I don't understand how with the cooling and the subsidence beneath the seamounts, you get some cracking and weakening, and
major landslides around the core of it, which is pretty hard, I guess. Maybe
and
it's
there's probably some very interesting currents around these collapsed areas.
Oh yeah,
leading up to the ridge.
Hopefully we'll be able to ascend this steep area. You know, last night we found that on Howland that we couldn't go up.
Yeah, yeah, we were at full up on our verts and barely moving.
Well, every seamount the biologists are finding, at least from that perspective, they're pretty unique. Can have differences from one to another. Still trying to figure out that what are the pattern, if there are patterns of in the geographic distribution of the corals and sponges that we're finding. That was fun last night.
Any interesting observations as far as the weather or clouds we've been seeing out here? Seems pretty benign.
We're in good shape. There's as we around 5 to 10 degrees north, that's the intertropical convergence zone. That's where we're going to see the towering cumulonimbus, maybe some thunderstorms. But that's where the trade winds are blowing to. Not right on the equator, but displaced a little north, just because the way land masses are mostly in the northern hemisphere. So it displaces that convergence zone. But so we'll see some weather on our way and to Johnston Atoll and around there. But hopefully no tropical systems. There's a hurricane in the eastern Pacific that should dissipate between Hawaii and the west coast.
Yeah, I think I saw that on Google Earth.
Yeah, I think it was Juliet.
There's almost a band of those starting from Dorian going west.
It's getting pretty active. Yeah, there's one in the Gulf of Mexico.
I'd heard a projection, who knows whether it'll hold weight or not, that Dorian could end up in Iceland or Greenland.
It would head up that way, yeah.
Wow.
It'd be an extra tropical low pressure system by that point. But yeah, with like hurricane strength off of the coast of
Florida,
Nova Scotia.
Oh, up that far north.
All the way that far north, yeah. This one's been a tough one for the forecasters.
Yeah, it just stalled over the Bahamas.
Yeah, oh, horrible.
Like 2 miles an hour or some ridiculously slow pace.
Yeah, catastrophic destruction there. So we have an interaction with Nell Herman's class on the 13th of September, but they narrowly missed them.
Where are they at?
She's down in the Bahamas now. Eleuthera. Passed north of them. And I think the Coast Guard is taking folks from the islands that got schwacked pretty hard down to other Bahamas.
Bahamas is a territory of the United Kingdom?
Yeah. Yeah.
Bottom in sight.
All right.
We're there.
And there's something down there.
Gonna log vehicles on bottom.
Perfect.
It's rocky.
On bottom.
Logged.
Hey, Gina, you back there?
Yeah.
Hi.
Hi.
Time is 0720.
Let's go to 30
Just jamming
instead,
out to those iPod
Get a
tunes.
holothorian to welcome
Check.
us.
It looks like it.
Check.
A welcoming committee.
That didn't come off. There we go.
So I've noticed that you usually back down and then have Argus spin around.
I do.
That's the right way to do it.
Thanks.
A lot of people back down, turn the vehicle around, drive under Argus.
You can do that too.
You can, it just
I
takes
think
more
so.
time.
The thing that's risky about this is getting the tether all wrapped up.
Oh,
Yeah, because you can't see it.
right now,
Can you
or
please go into auto heading?
yeah. How would I do that? Cool. Thank you.
Back on SPL.
Hey, missed you.
I doubt that.
Well, I mean, you're right.
Who's your roommate, Trevor?
My roommate is Sam.
Oh.
Where is she?
Science Sam?
Science Sam.
Got a fish down there. Fish. Right on the lasers. Oh.
Full beans down.
Full beans down.
FBD.
That's, yep.
So,
Where you
Emil,
going?
you were talking about the star-shaped
Yeah,
area of the seamount
you should
that
come to port,
we
though,
are
not to starboard.
exploring, or the cross-like shape.
You don't want to
One
do
of
a
our
full
viewers
loop
is
ever. You want to do,
wondering
like,
if
as
there
minimal spinning as
are
possible.
any other general alternates and shapes of seamounts, aside from the usual mound
So you're
or
gonna
round option that we see,
what's the bearing to
and
target?
what is influencing that.
290.
290.
If
You can line
it's
up at 290.
during currents, temperatures during the formation,
I
or
think it's just the way the lava flows and then the mass wasting, you know, the erosion that occurs as it cools. I'm not aware of too many different shapes, but we do get flat-topped seamounts from Gios.
Is that Holothorian, Gina?
Yeah.
Supposedly,
like
or
That's a strange looking one.
yeah,
It's got
kind of
spikes
big.
on
It's
it.
big, too.
It is.
Ooh, what's that thing to the left?
spines.
Little tripod fish.
Yeah.
Nice.
So what we could be seeing here are the result of the landslide, you know, chunks that tumbled down. Doesn't look like nodules to me yet.
Already.
Shrimpus.
Yeah, you're right. Okay, let's do some stuff here. Let's do these two.
There's what appears to be down there on the left, large, I would call it
The
a Holothorian deposit.
Yeah, it's a
Yeah.
deposit of
Yeah.
somebody.
4, please.
Dance around that one.
You looking to make a withdrawal?
So to get back to those shapes, Yashira, some
Yeah.
have conical, like you'll see the volcanic crater on the top if they haven't been exposed to the surface, and if the, you know, the dome collapses.
Could you come double wide, please?
After the
Double
seamount
wide.
cools, you might see a crater. This one
Okay.
did
Oh,
not
nice and
appear to
slow.
have a crater. But the
Thank
ones
you.
that are flat top, the Gios, yeah, they were at the surface and the erosion flattened them out a bit, and then the subsidence, the cooling of the crusts, caused them to sink down below.
Now this process is happening over thousands or millions of
Millions,
years.
yeah. You get
Can I get a bubble on one again,
island
please?
and then coral atoll, and then all that's left is the flat top, the Gio.
Let's try that. Okay, all right, Ed, I'm good to zoom, please.
Coming in.
I'll try to put it off to the left a little more this time.
Nice.
Yeah.
Look at that. Perfection.
Huh, black balance already looks good. All right, I'm going to go ahead, black balance the camera. Just going to make it go dark for about 5 seconds on purpose, starting now.
On purpose.
Yeah, that was pretty darn close. And yield white balance. Preset? Not sure I heard that beep. There it goes. We are ready to rocky rolly.
Rocky Rolly,
I'm going to give it a...
preset 4, please.
Before you come out of Auto XY, I want a couple more points here. If you
Roger,
don't, if you
no
don't
problem.
mind.
Currently not minding.
We're deep, so the interrogation rate's slower, so we don't have as many points.
Understood. All right, I'm all done with that.
All right.
How's your Z bias doing?
It's getting there.
Hopefully you're pretty light.
So as we transit up the slope, we'll keep our eyes peeled for the nodules would be potato shaped and maybe 4 to 6 centimeters in diameter. Not huge.
I'm gonna go with that. What do you think?
Looks grand. I haven't been watching, so I just completely trust you.
I think it's grand.
Ready for out of autos, or are you?
Just fussing. Ready.
Okay, you're good.
Good.
Okay. Does that mean we're good to move?
Good to move.
Yeah. Yep.
All right, we're going 290.
290I.
And I hope you guys like ascending, because over the next kilometer we will be going 600 to 700 meters up.
All right.
Ascending. Roger.
Bridge nav. 30 meters, bearing 290. Thank you.
My bias is looking okay.
Dialed.
So it'll
How's our
take a while
sonars?
for these movements to kick in at this depth.
Real. That one's all patchy.
Yeah,
we
is
should
it too
timed it.
fast?
Rennie, were you out with me when we timed the time to start a move?
Yeah, I think so. It's depth dependent, and
I don't remember what the depth was, but it was 4.5 minutes. Depth is an important variable in that equation.
yeah. Yeah, if it's if we're in hundreds of meters of water, you can really move Argus around pretty swiftly.
So we got some time. Maybe we can just kind of move along this rocky rubble. And
I wouldn't mind looking at that holothorian that was back to
Yeah.
port.
The spiky
That-
one?
Yeah, I had not seen that one before.
Let's have a gander.
And I'm sure Gina will know instantly what it is for us.
Oh, definitely.
Holothurian Whisperer.
There it is.
yeah.
Yeah.
Most maximum gain.
How long do you
Can I
think
turn
that
down?
is?
Yeah, please do. That's disgusting. I changed the TVG.
I think
A small one near it.
I think it's the core date.
No, it's not. Oh, that's my go-to answer.
You've ruined her head.
And I can guarantee you it's not.
hey,
It's not the only thing I can do.
we got a joke out of her. This
It looks like
this
it's
is
painted
good
with
sign.
that paint that absorbs all light.
Yeah, I think so.
Like you
Okay,
can't
go ahead and zoom in. Let's look at the small one first. Let's build suspense.
Little one's active.
Yeah.
He's
He
all
got his tentacles
Oh,
out.
What the heck?
He's trying to swim.
I don't think so.
Huh.
Are you like,
It's just rolling.
yeah.
Yeah.
It looks
Yeah.
alive though. It's
Long
got stuff on the inside.
Whoops. I'm not used to seeing those tentacles like that.
Oh, what's in front of the one on the...
It's steep here.
He's on his way down. All right, let's look at this stuff over here.
Help! I'm staying partial.
Wow.
That is
Wow,
dark.
That is
That's
really
pretty
dark.
cool,
It's even
yeah.
absorbing the lasers.
Deep
Yeah, that's
purple.
wild, actually. Good, good
Huh.
observation on
Look
that.
at that.
And it's huge.
What? It's
Hard to
invisible,
tell how big it is 'cause
probably.
you can't even see the lasers.
I'd love to
It's
get a zoom on that when you
Too
get
big
sorted.
to sample, I think.
Yeah. Could you come down on the delta, please? You can go to like 16 or something.
Can I come in a little tighter on this
Bridge nav.
guy? Momentarily, Ed.
Yeah.
Add one step, please.
Huh.
Which end's the front, Gina? The one to the starboard to right?
I believe so.
Yeah. Looks like he's run into a little bit of an obstacle. Or she has, or it has.
Okay, Ed, go in if you can.
They don't really tell me what their preferred pronoun is.
Looks
They.
very
What do you think? Is that in
purpley
focus?
red. Like a maroon.
Wow.
Chartreuse. That's not chartreuse.
Wow.
Look at
He's got a little,
that.
little termite on him.
Yeah.
That's not what it is. but-
Polychaete
Thank you.
of some kind.
Oops. What's down
Oh,
I
you
here?
got
think.
it.
I could be wrong about it, but
I'm all hung up on a rock. That's what's going on.
Oh.
Can you come out a little bit,
Yeah.
please, Ed? I'm going to
Little
step
or
over a little bit.
jumbo wide?
Whatever you think.
There's jumbos.
Wonder if the
Huge.
thing on the right, it's one of those xenophyophores. That
Oh yeah, the little brain things.
Okay, that'll be less tippy. Go ahead, Ed.
Yeah. Wow, it does just totally absorb those lasers.
That's really wild.
Yeah.
It's a good camouflage.
Yeah.